Hello and welcome QST readers worldwide. I'm Dave Kassler, amateur radio call KE0OG, and I am the author of the Ask Dave column in QST. Now, along with each column, there's a video supplement that just takes one of the answers a little bit further. And in this case, it's the question down at the bottom of the page about the HF bands being noisy. And there's quite an explanation in here, but what is at the top of this is a screenshot from SDR Uno, which is a piece of software that goes with the SDR Play receivers. Notice this is a negative. I've found that in print it's easier to see the negatives because you can see this. Otherwise, this would be mostly black, and you'd have a few occasional lines in here. This is just easier to see. But for this video, I think what I'll do is just use it as is. Now, I have on the screen here the complete 20-meter band. The signal path for this is from my MFJ hex beam into my ICOM 7300, where I have a little board in there that takes out right after the RF amp and the filters, band filters, and then sends the raw RF over to an SDR Play RSP1A. That's Radio Spectrum Processor number 1A. That goes then via USB to the computer, and what we're looking at here is the display that we get. Now, I've done a couple things on the display to make it maybe a little bit easier to see. First of all, this is the actual spectrum, the real-time spectrum of what is going on the band. Okay, and the way this works is it's measuring signal strength, okay, across the band, and down at the bottom here where there are no signals, that's kind of the band noise. And if I put the receiver in here, I'm getting about S3 to S4 noise, okay? So that's the background noise. Now that noise comes from thunderstorms around the world. The thunderstorms, that big bolt of lightning is a spark, just like in a spark transmitter, and it creates quite a bit of radio energy which bounces around the world courtesy of the ionosphere. Okay, so what we're showing is a spectrum. This is what is happening at 14,000. Up here is the middle of the band, 14,175, which should be about here, which would be halfway. And then all the way up to here at 14,350, which is the top of the band. Okay, now what we're looking at right here is Morse code, CW. What we're looking at right here is FT8. You can see how popular FT8 is. Up here is some other digital signals. And then we get up into the voice bands here and all the way up to here. This is recording single sideband. The spectrum scope is, like I said, from SDR Uno, and it does have a receiver in it. And the receiver is where this vertical line is pointing. That's what it will receive. Now that we've looked at what the spectrum scope looks like, let's look at the waterfall, which in my opinion is a far more useful display. Now, I put little lines on here that come up every 15 seconds. Every 15 seconds, that line, it was at real time. That's the time the line was at the top. And then as it goes down, it takes this value here and paints it as an intensity in terms of color. So we can see that there's a lot of CW activity going on right now. Between 14,028 and 14,040, there is some not much slow speed code, so I'm assuming that a lot of people on the air there. Now this right here is FT8, and if we were to put the receiver for that down here, we'll find that it's like 10 dB over S9. There is a lot of activity on FT8, and it's on very few frequencies. This right here, a little bit higher, might be JS8 call, something like that. Notice, I just want you to notice with these things here, these are all supposed to start and stop at the same time. So you can see the tremendous popularity there. Now, as we move up into through here, remember, this little part right up here is still CW. And when the CW comes slowly, and it's just a single one, you can almost read it off of there, dit, S, and so on. You can read it as it comes off of there. So the stuff at the bottom is the oldest. The stuff at the top is real time, and then it slowly drops down here. And this is real nice because you can spot a frequency where there has been action, and you might wonder if there's going to be action there anymore, and sure enough, there was. This is set up to tune in increments of 500 hertz. You can pick a different one you want. You can actually use this as a receiver and have a separate transmitter if you want. So what I've explained here is the spectrum part of the scope. This is signal strength plotted against frequency. This right here, along here, is the band noise. That's the amount of noise that's just sitting there on the band. And let's just move the receiver to one of those, and we can see it's somewhere between S3 and S4 if we move to an area that's not used. Now, if we pick a signal like this one right here, and we're going to go there, that signal is coming up and down over here, definitely readable. Okay, this thing says that the signal to noise ratio, it doesn't give it here. The SNR is 17 dB, 15 dB, okay? And that's great. That's a good signal to noise ratio where you can hear very clearly. Now this right here for FT8 is a composite signal because of the number of people who are on there. And these, all these CW here are individually visible. Okay? So what we've done is we've looked at the difference between a spectrum scope, which just gives you this upper part, and you only see the signals when they are actually transmitting. The beauty of the bottom part, which is the waterfall diagram, is that you can see up to about, close to 30 seconds into the past, depending on how you set it up. And if there's been some activity, you can go look and see if there's any further activity on that frequency. Like I said, I find this far more useful. Okay, so that's it. We've looked at the difference between a spectrum scope and a waterfall diagram. Many modern receivers have both. Some of the older, but not too old receivers have just the spectrum scope. My old Ten-Tech Jupiter had a spectrum scope that did the sampling only when you told it to, and so it just go bloop and then give you a constant picture. That wasn't terribly helpful. But when I moved up to an FTDX 3000, I had all of this, and of course my ICOM 7300 has all of this too, in addition to a spectrum scope for the audio, just the audio spectrum, and a sort of a little oscilloscope feature so you can see the modulation and things like that. Very interesting things that you can do with these receiver aids. So there you have it. I just wanted to tell you a little bit more about the spectrum scope and the waterfall diagram and some of the things that you can do with them. And so until we next meet for the July video, 73.